Okay, we're starting a brand new topic, sketching graphs. Pretty tricky. So we're going to do absolute values. Do you remember absolute values? Yes. So we're going to sketch graphs with absolute values in them. We're also going to do reciprocal graphs as well. So in case you forgot this stuff, a math relation can be a set of ordered pairs, for example, those three, or it can be a rule. Do you guys remember domain and range? Just starting with the basics before we get more complicated. It's possible to place restrictions on domains and ranges. So in case you've never seen absolute values before, it's just the size of the number. That's what it's determining. So there's no negative signs. So whatever operation happens, the absolute turns it into a positive answer because it's just the size of the number that we care about. We don't care about the negative sign. So pretty much x could be 5 or x could be negative 5. Because 5 times 5 in the absolute values is 25. 5 times negative 5 is also positive 25. Okay, example 2. If there was no absolute values, absolute signs, the up and down lines, what would you do? If there was no absolute, you could use gradient and the y-intercept, or you could sub in some numbers. But that's just for y equals 4x minus 2. All of these negative y's are positive. So there's some point where the negatives, instead of continuing down, it's going to bounce back up and make a V. So we're going to figure out, and what point would that be? When what equals 0? When y equals 0. Very good. X is a half. So at this point, x is a half, it'll go like that. And I'm going to use technology because I'm feeling lazy today. So ABS gives you absolute. Alright, let's now do our comparison. How are they different? How are they the same? So anything outside the absolute doesn't get affected by the absolute, right? So it's bringing that point of reflection down. If we don't put the take 2 inside, it's bringing it down. So the y equals negative 2 is now the reflection line. Okay, so same gradient, reflection point is different. So for 3, the reciprocal is 1 over 3. Alright, so we're going to move on to our next thing. We're going to sketch reciprocal function. So if we've got the function y equals 2x plus 1, let's sketch the reciprocal. What is the y value when x is negative 2? So we then graph it. Okay, now if we look at the inverse function, there's some point when it's 1 divided by 0. And for this normal function, what is that point? So when y equals 0, what's x equal to? Negative half. So the reciprocal function this is called undefined, or it's going towards what? infinity. It's going towards infinity. Okay, so if you've never seen this sketched before, so the original 2x plus 1, the reciprocal. So at x is negative half, you can see it's going towards plus and minus infinity. What about this one? And what type of function is that? Quadratic. So where's the asymptote?
There and there.
X take 2. Surprise! So what's the other thing you need to write down? So it's going, let's start from the left to right. So it's going towards, it's a flat line going towards the right, goes up and becomes an asymptote towards infinity, and then it drops down, continues up, doesn't cross the axis, and then goes back down, and then swaps. As it approaches the second asymptote, that's when it swaps to the other side of the graph, or that's when it reflects to the other side of the graph.